Alrighty, let's see what there is. Okay. So it's rotating the box today. You're given previously solved. You're given an n by n matrix of characters box grid representing a side view of a box. Each cell of the box is one of the following. It's a stone as an hashtag. Obstacle is an asterisk. Empty is a dot. A box is rotated 90 degrees clockwise, causing some of the stones to fall. Each stone falls down until it lands on an obstacle, another stone, or the bottom of the box. Gravity does not affect the obstacle's position. Inertia from the box rotation does not affect the stone's horizontal position. It is guaranteed that each stone in the box grid rests on an obstacle, another stone, or the bottom of the box. They turn n by m, so yeah, okay, so changed, rotated matrix dimensions representing the box after rotation. Okay. I like the visuals. This is much better than this stuff. Okay, I think I understand this. So it's rotating 90 degrees clockwise. Yeah. So the obstacles stay where they are relatively. And then this one would shift down, so therefore it's on this side. Okay. So I think this can be done in two separate. Yeah, I think this can be done in two separate type of operations, I want to say. Could maybe even do one, since like two different transformations can combine to some sort of meta, or not meta, some sort of aggregate transformation. But the simplest thing would be to think about the rows and shifting all the elements in the rows kind of rightwards, as if there's a gravity force on the right side. And then once you have that, just rotating it, and that's just a simple, whatever code to rotate a matrix. So the question is how to push the matrix rightwards. How to push the matrix rightwards. Yes. Feels like I might want to use a stack. Guess I might want to use a stack. Maybe a stack is actually too. Maybe a stack is actually too complicated. If I iterate backwards from right to left. If I iterate backwards from right to left, having some sort of two-pointer system, where kind of the right pointer is where I would shift the next. Like if okay, so what I'm thinking of is if it was a single row, and the row had, let's say, I'll use F, so flower, empty spaces, flower, empty spaces, and then say Pouncer, I guess O for obstacle. Something like this, right? If this is the whole row and I'm shifting everything to the right, then ideally I want it to be something like the obstacles are where they are, and the flowers are shifted rightwards to the nearest obstacle or nearest open space then. So I can go iterate backwards 2 pointers. 1 pointer is where the last kind of open spot for shifted for shifted thing would be. So then it hits this F, and this F goes to this point. And then once it hits the obstacle and there's another free spot, then the destination pointer is here, and then this thing is going to move this F to the destination pointer moves here, then this thing moves this thing over. So yeah, so like kind of a 2-pointer for every row. Every row, shift the, what are these things called? These are called stones to the right using 2 pointers. Okay, so for, say, n is the number of rows. N is, say, rows. Actually, I'm just going to say rows and columns is length of the box grid, and then length of box grid at 0. For every row in the box grid, I need to index. So let's say how should I do this? I think this should be some, I wonder. Yeah, I might as well try this instead of trying something more fancy first. Let's say destination pointer is equal to columns minus 1. Is that right? Yeah, I think so. So for every index k in range, let's say -1, columns minus 1, minus 1, minus 1. If the row at this k index is an obstacle, then the destination pointer is going to go to k minus 1. So if it's an obstacle like this thing, then it's going to point here. And if there's another obstacle here, then it's going to keep on going before that. Else, if it's not an obstacle, I guess the other thing is if it's a space, it doesn't matter. If it's an actual stone, then it needs to move. Yeah, if it's a stone, and I guess maybe, no, if it's a stone, it needs to move. Row at k and row at destination pointer is equal to, should be now, what if it happens to be the same one? I guess order of operations. Well, I guess I'll double check it. So it'll be, the first should be made into a blank, the other one should be made into a stone. And then destination pointer should decrement. And I think that might be it. Let's go ahead and just print box grid after this. does it work correctly? K in range. Yeah, that's poor syntax. Okay, yeah, that moved rightwards. Yeah, so this stone went to be next to this obstacle, and then these ones didn't move at all. First row's fine. Second row's fine. Third row, the three stones moved all the way to the right. Okay, so that looks fine. So now it's just a matter of rotation. Alright, so I don't think, I mean, I could try to find a rotation library function here, but I'm just going to go ahead and just fill it out. Actually, can I? Maybe I can do a list comprehension here. So answer equals grid. So answers equal to what? Using list comprehension. So each row is going to be from each column, and I want to fill in row by row. So pulling column by column. So let's say it's box grid at row column for every C in range calls, and then for every R in range rows. I think that might work. So every column, is that right? I need to pull in from columns. So the first row of answers from the first column. First row of the answers from the first column. So I actually think this is wrong, right? This is yeah, it should be the other way around. So iterate over the outside needs to be the columns, and then iterate over the row indices of that first column. Okay, I think that's right. Sadness. Huh. Seems kind of backwards, it looks like. Yeah, that is backwards, isn't it? Oh, why? Why is it backwards? This one seems like this is really bad. Really, really bad. Am I going the wrong? No. Oh, yeah. Okay, yeah. Very bad. So once I have it moved, first row needs to be, yeah, this is really bad. This spot is actually from the bottommost column. It's from the bottommost column to the firstmost column, so it's going backwards in the columns. It's going backwards in the columns. So I think this should be cols minus c, something like that. Cols minus 1 minus c. I think that's it. Oh my god. So this, alright, just think through it, So I have it translated to the right, or shifted to the right. And then when I form this thing, this is for every form this row. Okay, let me try to just build it again. Box grid. Let's say RC. So this is from here. This is from here. This is from here. So I want to iterate over the row indices, right? Because yeah, I want to iterate over the number of rows. So is this going to be 3 rows? Just going to be the same size of this. And then for C and range calls. So this is roughly the correct order, rows inside, columns outside. Let me double check here. Rows inside, columns outside. Did I just go infinite? Why would this go infinite here? What? There's no way this is going infinite unless my internet's crashing out on me. Okay. Yeah, it's shifted to the right correctly. Okay. So box grid at RC. So for every, so right now, R is, this should be filling it from, so if this is 0, 0, if R is 0, C is 0, this should be pulling it out from, what am I doing? What am I doing for every R in range rows? So this is going from 0 to 3. So from 0 to 3, column is currently 0. So R0 needs to go to the reverse row. No. Let's go, yeah, let's go reverse row. This should be rows minus 1 minus r. That, hopefully. Oh, I need to return this, right. Well, finally. Well, enough trial and error, and the mouse gets to the end of the maze. Probably gonna crash on some stupid trivial case. Okay. Not very fast, huh? What was that other type of statement again? It's not a switch statement. It's a, man, I am so bad. What was the thing called again? Case, match case. God damn it, I'm never gonna remember this. Match case. I don't know if it's any faster. So it's match expression case. Match row K colon case. Case. And I think, okay, I guess I can remove the singleton declaration of a variable. Declaration assignment, then immediately return the assignment, or return the variable. So this should be the same. Let's see if my internet cooperates. Yeah, defining the rows and columns is useful. Okay, whatever. I guess it could be done in a single pass. Yeah, it could be done in a single pass rather than 2 passes like I have it here. But whatever. I'm fine with this. Or okay, so yeah, this is one of the definitely easier mediums, I'd say. Summary. Broke the problem, or sorry, decomposed the problem into 2 transformations. One to shift the stones rightwards, kind of going over 3 spaces between it and the next kind of obstacle / wall in the row, and another transformation to rotate the matrix. First, so the main part of the problem is the shifting of the stones, which can be done using using a nested for loop, backwards traversal over the row indices, tracking kind of with 2 pointers, backwards traversal over the row indices, tracking where the destination of the current stone would fall or would shift to in that row. Yeah, so you keep track of a destination pointer, basically the location where the stone would fall rightwards. You increment or you decrement over the row indices within that row. And if it's a stone, then no, it's not. If it's an obstacle, then you try to use the destination pointer to be immediately before it. If it's a stone, then you move it to the destination pointer and move the destination pointer back one. It should always work. There shouldn't be ever any crash cases. Finally, then use this comprehension to create the rotated matrix after shifting the stones in the original matrix. After many trials and errors, found the appropriate algebraic expressions to move the stones. Yeah, so it's going backwards in the rows was something slightly unusual. Time-plex is O of n squared, or O of mn, where box is m by n, since there is at least one pass over every element in the matrix doing constant work each. Technically, I did 2 passes, but it's still O of mn. Space-complexity, this is O of 1, since no extra space is needed. Alright,